and we'll just introduce some terms and your security, your vulnerability, and your privacy. Okay. So what is trust? So trust, like we do have a trust on our friends, close friends, parents, other people, and this trust concept we are applying when we communicate. When we communicate, we send the messages and receive the messages. Sometimes we tell secrets to our friends, and we trust on our friends that this information will not be disclosed by our close friends, or on which we do have a trust. We tell him or her the secrets, and we feel that these are not going to disclose by him or her, and that is the trust. If we don't have assurance regarding that this person, he or she, is not going to tell or going to tell, definitely based on this judgment we take a decision whether to disclose the secret or not. Same things are written in this words. We'll just read out so that you can understand. Trust. So in we are looking in form of ICS now. When we communicate, like two parties are there which are sending the messages, and to that point of view, this trust is looked at. Assurance that the received information will not be disclosed, which can harm the sender. So this is a trust. Sender is sending the message information to the receiver, and from receiver side, it is the assurance that whatever information is received by the receiver is not going to disclose, so that there will not be trouble, there will not be problems, there will not be harms to the sender. And this is the trust of sender on receiver, right? So assurance of safe use of data existing when things mean to say devices or systems or computing nodes, they are communicating. So when these things are communicating, there is an assurance of safe use of data existing, and this is the trust. Next is security. So what is security then? So security refers to the communication, especially data communication, from one to another, from one sender to the receiver, and data altered or does not reach to hands of unrelated entities. So this is the security which takes care. Security is for data when there is a communication from one end to another end, and this data will not be altered, will not be changed, as sender is sending as it is received by the receiver, and this is taken care while this communication is happening, so that this data should not be disclosed to unrelated entities which don't have this part in the communication. So this is a security. Suppose there are three friends and one is sending one information to two friends at a time. So apart from these three, this data should not be reached to any other party, any other friend. Only these two should be receiving. And this is care is taken, then that process is called as a security, right? I'm just revising the terms so that you can apply when we go ahead in this unit, fifth unit. Message privacy. I can say similar. So message not reaching in hands of unrelated entities, or no interference or disturbance when we send the message. So communication remain between two parties only, or two. Two mean to say one is a sender and one is a receiver. If there is a sender and there is a receiver, between these two only this communicated data remains. Others are not allowed. In fact, it should not be there. We take an example of home security application, right? So home security application, and by using a IoT now, which will have internet connection definitely. By using IoT, if I am far away from my home, still from that far away location, I can, using the devices, I can watch, I can have an eye on my home security, that who's entering, who's inside it, what is going on inside the home or surrounding environment. So I can keep an eye. And while I am watching it, these are the video clips, right? So videos are available. So these videos clips should not be reach to unrelated entity. If other also can capture these videos on net by breaching the security, and they can see, then definitely the security will not be there, because people can go at home and they, thieves or all those things can happen. So when on internet I am watching these video clips, as a video clip data should not be reached to third party or unrelated entities. And this is the privacy. So only between that camera captured and I am the owner, I am the admin, I should only watch those videos. So this is the message privacy. So what is message then? Message is a data, a string which represents data, or a client request or server response. So client can also send request, that will be also a data. Sender can or server can give the response to the request received by sender. That is also can data. So this sender, client and server are responding, they are communicating, and when they communicate, they represent a string of data, and this is called as a message. Suppose it is video file also. So video file is also converted into binary format, and that is the data, which is client is sending and receiver is receiving, and he can or she can give the responses, acknowledgements. So this is the message. Hash, you know it, hash, message digest, MD5 or something like that. These are the algorithms, encryption algorithms, which are taken care, so that if message we are sending, it should not be understood by, or if somebody captures somehow, he or she should not be understood, they should not be get the meaning of it. And these are the different algorithms at different levels. Though these 3 4 algorithms are different from each other, and all are providing the security. So one of it is hash. So hash refers to collection or bundle which gives an irreversible result after many operations on that, and the operations are just one way. So if I apply a hash algorithm one on one value, it will give a hash value by using the algorithm hash. And so that I can transfer this. If somebody is doing capturing this and he is trying to do different operations on it, definitely it is not possible to get the original message. Then how the receiver identifies it? How receiver receives the message and he encodes it? So how? So again, similarly, using different operations, it will have sender receiver will have also this algorithms. He will use that algorithm. He will get the value, and already he do have that value stored. He will compare and then he will confirm that this is the sender who has sent me this message, not somebody else. So hash value can have 128 or 256 bit, which creates as a hash. So these are the hash. There are different hash algorithms which we can apply. Different, I mean to say, hash one, hash two, like that. You know it better because you already studied ICS, right? Hash algorithm. So this refers to a set of standard operations which we can use, and we can securely create hash values. The algorithm refers to generate a fixed size, say either 128 or 256 bit value using a secret key. If values are more, the security is more. If we compare 128 and 256, 256 bit secret value will give you more stronger security as compared to 128. So these are the algorithms which are nothing but it is a set of some standard operations which are applied, and so that we can create a hash value using the secret keys. And there are different sizes of secret keys: 128 bit, 256 bit. We don't know, in future maybe it is going to increase more than that to provide high security, because nowadays the wireless communication, IoT, and these kind of things are coming, so the communication is very much increased on this air. You can say wireless communication is more. There are Bluetooth, there are hotspots, and all those things where the people join, they access the information, and when they accessing, this network is open. And when these networks are open, there are chances that some third party can access, can capture these messages. And if at all these messages are captured, these are the algorithms: hash algorithm, message digest, as I said, encryption algorithms, which prevent user or other third parties from accessing exactly what original data it is, what original message they are carrying. Communication happens. So this is a hash algorithm, just introduction. Already you know it, I know, but we are just revising it so that when we go ahead in this chapter, these terms will take the part, or you can understand the meanings of it. So next is hash for authentication. Can we use hash for authentication? Just now I said. So how it happens, we'll see example. When data such as user ID and password needs secret communication for the purpose of authentication, then it is communicated after applying a hash algorithm, and only the hash value is communicated. So when there are two parties, or when sender and receiver is there and they are communicating, and if the data is very sensitive like user ID and passwords or secret keys are communicated, then purpose of authentication comes in picture. Then I, as a receiver, I need to confirm that this messages came from my friend only, not third or any other person is included in that. And how it is confirmed? So receiver end retrieves this hash value, compares that with stored hash value, and if both are equal, then the sender message is authenticated. It means we confirm, yes, the hash value is same. It means this is the sender ID, or this is the sender who has sent me the message. And how I am confirming? I am applying hash value, hash algorithm. I'm getting an hash value, and already, suppose particular X standard is there. His user ID, I know it, and that reflects in hash value, and both hash values are similar. And then I can confirm that yes, the sender is X. This is how the authentication is done, and for that purpose, we can use this hash algorithms. Next is, as I said, MD5, very popular algorithm nowadays. It is different than hash, and I can say a bit stronger than hash. So MD5 is used for message digest. So process which gives irreversible. Irreversible means once we convert, then it is not possible easily to again reconvert it or get original message. Okay, so just will send a particular message by using this kind of algorithms, and these algorithms include not only single operation. There are different algorithms inside it, small operations, and which converts that value in you can say different combinations, which is not possible to easily to recover. That's why we said these are irreversible results. So process which gives irreversible result involving many operations using a standard algorithm such as MD5, and that is very known message digest 5. Digest result is similar to the hash value. Again, it is similar. but the operations which involve in hash and MD5 are different. That's why they are different algorithms. Receiver receiver end stores this digest value expected to be obtained after MD5 operations and compares that with received value. And if it is matching, then they can confirm authentication. That message is received properly from a trusted party. And this is the message. So if both are equal, then sender message is authenticated. So this is one more algorithm, message digest MD5, message digest 5. Very popular algorithm nowadays. Encryption. Encryption, already you know, we convert our plain text, right? Plain text, which we call as a simple message. By using this key, convert by applying encryption algorithms, we convert this plain text into ciphertext, right? So process of generating new data using a secret key known only to a receiver, and we can as a sender and receiver can communicate by using these encryption algorithms. So before sending the encrypted data, sender and receiver both identifying each other and both know the key which is going to use by these two parties or by them. So encryption using 128, 192 or 256 bit key for encrypting data. So there are different encryption algorithms which we can use. Even I can say hash is also encryption algorithm, one of, where we use secret key, we convert our plain text into ciphertext, and then we send. Just the names are different. Hash values, message digest or message, or encrypted ciphertext. These are the different names. The processes will be different, but end result will be same. That your plain text will be converted in different form, which is not readable, which is not identifiable, which don't have any kind of meaning in it. So when there is encryption at receiver, there is a decryption. So process which retrieves the data from the encrypted data is decryption. Use case. Up to this, anybody have any doubt? Anybody? Is it okay? Am I fast? Is it the speed is okay? These are the terms already known by you. So just we are revising. Meanwhile, we'll allow those who are in waiting. Okay, only one person. Anybody have any doubts? Shall we go ahead? Am I audible? Yes, okay. I got the response. No problem. Use case. I think your UML, you know it? UML? Unified Modeling Language. Maybe you're used for your third year mini project where you converted the project concept into diagrams. Okay, no problem. Maybe next time you do have this UML where you are going to learn, or any kind of workshop where you are going to learn how the UML diagrams will be there and how we can represent each a single part which is present inside our project. Use case. Use case means a list of event steps or actions which define the interactions between two ends. One is playing the role and other is the system. Simple. I'll take a simple example. Suppose you are making a login to the application or any system. So login means, so you first give your identification, and that is your user ID. So you type your user ID and one password is assigned to you and you type it, and then system checks if the already created users are there and whether this name belongs to that list. Once user ID is confirmed, whether the assigned password is entered by you. If both are matching, then what system is done? System is doing taking some action that it will allow you to enter. Suppose your user ID is not matching, then system, what system does? System takes action, and that is it will give you error message. Please enter correct username, or it will not allow you and give some this kind of different messages, error message. If user ID is matching and password is not matching, again it will ask you to enter the password. In some systems, there only can have 3 attempts of using the password. And if 3 times your password is incorrect, it indicates some third party is trying to enter and trying to guess the passwords. And for whole day, it can block. So these there are different actions and steps which are decided. So use case is gives this information that currently what kind of communication is happening and between whom. So there will be one is playing a role. So I am the user, I am trying to enter into the system, and at other side system will be there which checks whether you are the authorized user or not. So representation of this using a diagram is called as a use case. And we try to draw all these kind of communications which are present, and how many such playing role actor which is called as actors are there, and systems are there, and how this entire things is going to communicate. If after once we make a login to the system, if suppose I'm adding one user, so how the adding user will be taken, who will play which role, who will take which actions, all these steps and actions are defined, and those are defined in form of communication, form of interactions, that is what we call form of diagram, and that is use case. And UML will give you, this is a language, unified modeling language will give you this how to draw all these things. So the used step accomplish a task or goal or a mission, and other end, the actor in unified modeling language will be there, and at other side, the system will be there. That is end. So this is how the entire all these communications, interactions are happening will be shown by using this use case. This is just introduction. We are going to see one example, use case example, and where we are going to go for misuse also. Misuse. So that is the next misuse case. If I enter user ID and password correctly, what actions we are going to take, steps are going to take, and who will communicate, who will send user ID and password, and who is going to check all these things we define in use case. What should not be happening, that we tell using this misuse case. So misuse case refers in reverse sense of use case. Defines, so misuse case defines the behavior which is not required from the software under development. Misuse like what we should not do. Our system will try to do this, and what actions we should take. आपण म्हणतो ना की हे करायला पाहिजे, हे करू नये. हे करू नये म्हणजे हे मिसयूज केस आहे. आणि हे व्हायला पाहिजे, हे असायला पाहिजे, ह्या स्टेप्स घ्यायच्या, असं झालं तर असं करायचं, दॅट इज यूज केस. आणि असं असेल तर असं करायचं नाही, असं कोणी करायचा प्रयत्न केला तर ह्या ऍक्शन्स घ्यायच्या, असं जे आपण डिफाईन करतो, दॅट इज मिसयूज केस. So this defines the behavior which is not required from the software and which is going under development. So defines the behavior which should not happen like this. And also this misuse case defines the threats. की असा असा धोका आहे आणि हा असा धोका असेल तर काय करायचं, that is also it gives information. So these are the misuse case. So gives information and renders help in identifying the requirement of new use case so that we can prevent attacks and find out what should not happen. असंही करतात काय काय जण, युजर आयडी टाकतात, पासवर्ड नाही, मग फॉरगॉट पासवर्ड म्हणतात आणि त्यांचा नंबर देतात आणि ह्या नंबरला पासवर्ड पाठवा म्हणतात. मग आपल्याला तिथे कन्फर्म करायला पाहिजे सिस्टम. मग हे मिसयूज केस मध्ये येतं. सिस्टीम सांगते की असं असेल, फॉरगॉट पासवर्ड असेल तर परत त्यांना एक सिक्युरिटी क्वेश्चन विचारा, की ज्यांना आपण परत एकदा पासवर्ड पाठवणार आहे, वी आर रिसेंडिंग द पासवर्ड, देन whom we are sending, is it trusted? So there will be a security questions. सिक्युरिटी क्वेश्चन चुकले तर अदर मेथड्स असतात की असं तसं तुम्ही टाका तुमचं जीमेलला, जस्ट गो इन साइड द जीमेल, type your user ID and type wrong password. It will ask you forgot password. Go in the forgot password. It will ask you the G code. It will give you information that we are sending the only starting two digits and ending two digits of the number which you have registered, the code to this number, and please enter that code. If you are original person, if you are the user, definitely you do have this mobile number and this information. When code comes, you can enter and you can go in. So those who are trusted, they can give this test and can pass. Those who are not trusted, definitely they don't have this number, they don't have the message, the code which is only sent to that number, and definitely they will not be able to enter, and automatically they are not going to allow to log in. सो दिस इज डिफाईन्ड. हे सगळं ज्यात लिहिलं जातं, इन्फॉर्मेशन म्हणा, नियम म्हणा, बिहेवियर म्हणा, सिस्टीमचं काय असायला पाहिजे, द सिस्टीम बिहेवियर, व्हॉट शुड इट शुड बी वेन दिस हॅपन्स, all things are written in misuse case. So there are two terms. One is use case and other is misuse case. Next, layer. So these are the terms which are we are revising. Okay, so these are the definitions. हे काय असं हे आपण आता सांगतोय. So we are telling what is meaning of this, so that next actually when we start, these terms will taken care, they will come, so that you can understand it. Layer means a stage during a set of actions at which the action is taken as per the specific protocol or method. So we are going to take actions and we are going to follow some action, a specific protocol or methods as an action. And when we do this, there is a stage during these actions. At what particular step what we do, next step what we do, next step what we do. Like all these are the layers. So we define in layer, suppose first three actions, in next layer, next three actions, like that. The result passes to next layer or upper layer until the set of actions completes, as I said. So when we go in the bank, first we go and take the withdrawal slip and write what we want to do, if we want to withdraw or we want to deposit, right? Then that message and your identification is given to one person. They checks your sign and all the authentication. Then they pass and that goes to next level. Then again they do some processing. Then it goes to next level, that is cashier. Then cashier confirms and there is will be a one kind of a token which you received when you are submitting that withdrawal slip to the one particular you can say person or on table. And once you give that token, he will give you the money, right? So these are the steps written. So and these are happening at different layers. So such layers are included, which defines which actions taken. Layer models. So there will be models which are following these layers. Design using the layers, enabling representation of set of systematic actions which are followed sequentially for accomplishing a task. As I just right now we have given the example. So there will be a model which is using this layer model. All the actions will be performed sequentially. Sublayer. So there is a layer inside it, some part. A layer consisting of various sublayers in the model. Again, which sublayer will provide a set of actions which are sequentially taking place at layer. So inside of one layer, there can be sublayers, and sublayers can have number of different set of actions. Firewall. Hope you know it. Firewall, which is a refers to as a software interface. Software. Firewall. आपला तुम्ही सिस्टम यूज करत असाल, if you are using system, laptop or desktop, let it be, and if you are connecting to the network, definitely there will be a firewall system which takes care that the threads untrusted parties, all these kind of requests will not come to you, so that your data will be secure enough. And if they are there, if somebody is coming, it will give you the notification. Yes, this kind of threat is detected, and it will ask you also sometime that way, what action you want to perform on this, whether you are going to allow or you want to delete. And if you delete, this history is taken care by firewall. So next time such threats are similar threats are coming, automatically firewall takes delete action. So these are the software interfaces available. So firewall plays a very crucial role nowadays. Remember, interconnecting networks with different different trust and is immune to penetration, providing perimeter defense. Different kind of trust we do have, different kind of people, different kind of parties, different kind of communication taken care, and this interconnecting networks depending on the different trust allows. Also it allows to enter inside your system, and the message goes from you to another system. So that is penetration, providing perimeter defense, providing the security, that is defense. So functioning as a choke point of controlling and monitoring. Valid people are coming, allow them to enter. Invalid are people coming, they are stopped on the gate itself, and they are not allowed to enter. So this is the controlling and monitoring which is happened by firewall as a software interface. Allowing only authorized traffic, as I said, imposing restrictions on the network services, raising alarms on abnormal behaviors. As I said, if there is a threat, it will give you notification. हे हा अनोळखी व्यक्ती यायला बघतोय, काय करायचं याला, असं विचारत होतो. सिंपल टर्म्स मराठीत म्हटलं तर. So somebody unknown is trying to enter, what to do? So we check and we give the signal. थांबवा त्याला, हाकलून द्या, बाहेरच पाठवा, येऊ देऊ नका आत गेटच्या. Automatically this firewall is taking that. So controlling and monitoring. So this is your firewall. So these are some terms which we have just introduced. So we'll summarize. So we learned microcontroller, embedded system, embedded devices. We haven't taken care of these things. We have learned these terms: module, header, jumper, ID, operating system, RTOS. No, we haven't learned this. We have learned trust, security, message privacy, message, then hash algorithms, then the message digest algorithm, hash for authentication, MD5, encryption algorithm, decryption, use case, misuse case, and then layer and sublayer. And finally, we have learned firewall, right? So any doubt up to this? Anybody? So anybody have any doubt? We'll go ahead. We'll see the introduction of security, privacy, and vulnerability attacks in IoT. So screen is visible?
Yes, sir.
Okay, we'll just introduce so that you can have the idea. So next lectures, we'll go in different concepts. So message, you know, privacy, you know, security, you know. So we'll see message privacy. Privacy. Sometimes we tell secrets to our friend, which our parents also don't know, right? And they are never get to know. What is this? So this is your message privacy. What I said? Sometime you tell your secrets to your only close friends, but you don't tell to your parents, and you do have the guarantee, right? That parents are never going to know this. At one side, this is called as a message privacy. So to whom who have shared, he or she and you, only these two people know it. Others never know it. Never known, get known to this in future also. And this is your privacy. And regarding message, so it is a message privacy. So message not reaching into hands of unrelated entities. And if you feel those are parents, so parents also will come in unrelated entities if we don't want them to know these things. Don't take personally, just I'm trying to tell you. If something is there, we feel this should not be known to the particular person, and we know to whom this message or this information should be known. So automatically this indicates your message is going to be private, and only these two people will have a trust, and they will keep this private. So they are not going to share to anybody. So automatically it indicates also that unrelated entities will not capture, will not get this information, and this is privacy. So when data or messages communicate from the things, now we are coming inside the IoT. Things, again, those will be devices, those will be sensors. So sensors are supposed to send the information to only the particular, you can say, APIs, through particular, you can say, platform or interfaces, network interfaces available. Only those APIs should get that information from the sensor. Other should not be. So such a way it is a privacy, message privacy, which happens between the sensor and the API, application program interface, which takes care from the particular sensor to receive the data. That is what I am saying. So those are only for the applications and services and for targeted goal only. So this message will be communicated only to applications, only to services, or for a particular targeted goal only. So privacy means no interference or disturbance from other, right? So this is your message privacy. Why we need it? Need of privacy. So consider example of messages from embedded devices in automobile using internet to an automobile service center. Now we'll see embedded devices. Embedded devices, there are number of different devices which are at single will work, so that particular things, particular messages can be communicated to from one point to another point. And we take the example of automobile system. Automobile service center is there, and using an automobile, using an internet, there are a number of different embedded service devices which sends the messages to the automobile service center. So privacy means, already we have learned, the messages reach only to the parties, and in this case only to the center, and used by only the services of center, right? If suppose another automobile company receives this information, whose hands on the data falls, it means they receive the information, another automobile company, that indicates that all the secrets are known to the another automobile company, and then company, original company, can face serious business consequences, right? So this is why there should be a privacy, so that some unrelated person or unrelated, you can say, system should not have this message. So that is a need. So what is IoT privacy policy? Needs to determine that how much of the IoT devices data and which data need absolute privacy and which limited privacy. It means we'll have particular devices will communicate, they will exchange the messages, and there we require that some other parties, some other sensors, some other APIs, some other interfaces should not come into picture. Only these two parties should communicate. Then this is a absolute privacy, and also which we can term as a limited privacy. Suppose first sensor receives the data or sends the data, and it is supposed to send that to the next node, sensor 2, and sensor 2 is supposed to communicate with the API. Then that should be like this: sensor 1, sensor 2 to API, API to sensor 2 to sensor 1. So this is how the communication will happen. In between, no other sensors, no other APIs, no other devices will come in picture. This is your IoT privacy policy. Vulnerabilities of IoT. What is the time we do have? Okay, 2 minutes. Just within 2 minutes, we'll finish this, then we'll stop. In English, vulnerability means weak, without complete protection. Weakness to defend on oneself or can be easily influenced from surrounding unwanted things from itself. So vulnerability, it means for a system there are some lacunas which are not protected, and so that we cannot defend. So easily one can enter. Suppose the school is there and it will have the wall, protecting wall, and there is a one gate. But at other point, the wall is broken, and from that point, anybody can enter. So automatically, this indicates there is a vulnerability that rather than using main gate, somebody can enter through that broken wall and can enter inside the school or college. So this is your vulnerability. This indicates complete protection is not there. So there are some weaknesses, and which can be influenced by surrounding unwanted things, and they can enter inside the system and can make harm. So IoT vulnerabilities due to participation of number of layers, hardware sublayers and softwares and applications and services. All these are there. So there are some uncompleted, or in fact I will say unprotected things will be there. So there the protection is not there, so that others can, this is a possibility, others can enter through that and can receive the messages which are they are not supposed to receive. They can access the data which they are not allowed to receive or not supposed to receive. They can use the services which are not supposed to get it. So these chances, possibilities, weak protections, lacunas, weaknesses in the system indicates there is a vulnerability. Okay. So we'll stop here. Then we'll go for next time the next things, that is what will be the types of vulnerabilities, and then how we are going to provide a security in all this stuff. Okay. Stop sharing. If anybody have any doubt, they can ask. Anybody have any doubt? Are you clear? Just introduction of similar things which already you know, revision of ICS I can say, so that next time when we go ahead, definitely you can identify it. So any doubts? Now start typing your roll numbers in the chat box so that we can take the attendance. Type your roll numbers. Everybody, those who are present, 34 people are there. So type your roll numbers in chat. So automatically this is going to be counted as in your attendance. So 14, 12, 1, 21, 31, 43, 56, 46, 67, 70, 22, 47, 56, 48, 61, 52, 16, 26, 33, 58, 30, 29, 45, 27, 51, 24, 64, 42, 50, 63, 55, 53, 54. Anybody's remain? All have entered their roll numbers. Okay, thank you very much. We'll stop here. Stay safe, take care, and keep watching videos. I am going to upload this on YouTube also. It's all the quizzes. Thank you. We'll meet next time for next lecture. You can leave, no problem.